Sorry about that. All right, so yeah, now I just want to review some basic bash commands that you'll be using all the time. These are the most fundamental ones. So we'll start with pwd. Hang on. Sorry, okay. Just wanted to get some syntax highlighting so you could see things in different colors. Had to change the file extension real quick. So pwd, print working directory, just tells you where you are. If you don't know what's going on, that's a good command to type. Maybe your terminal will tell you something you weren't expecting. So the second basic command that you should know is ls, which is just short for list. Basically tells you all the files that you have in the current directory. So right now, the folder I'm in, it only has this one file. It's this notes file that you can see on the other side. And so that's what shows up in my command line when I type ls. Okay, third command I'm going to show you is cd, which is change directory. So up until now, I've just been running a couple commands in the same folder, but we need to move around our computer. So I'm going to use cd to go to a different folder. So now in order to use cd, I'm going to have to pass it an argument. It means I'm going to type in a second word that tells cd what directory I'm operating on, what directory I'm moving to. So for example, if I type cd/, this takes me to the root of my computer. / is the folder that contains all other folders. Type ls, shows me some other folders here. I'm going to try to get back to my home folder. So I'm going to go cd home, type ls. What? Oh, sorry, that's actually not the folder I thought it was. I meant to go to cd users. Okay, sorry about that. So we're in /, going to users. There's the shared folder, and then there's the one with my name on it, my user account. I'm going to go into my user account, cd Rafael Sirota, code, demos, Quebec. Great, now we're back where we were. So just a fun little shortcut for you. If you just do cd tilde, this always takes you to your home folder. So tilde is just always an alias or a shortcut for your home folder. So that can be pretty nice because you can write scripts that'll run on multiple different computers, and you don't even have to know what the home folder is named on those different computers. As long as you refer to it with tilde, you know, the script will go to the right place. Right, so I cd tilde, pwd, and it shows me I'm in /users /Rafael Sirota, the folder with my name on it. That's my home folder. That's where cd tilde takes me. So now I want to show you another way that we can modify what a command does. I showed you, passing in an argument to cd. That's the main way you tell it what to do. but there are also options you can pass to these commands. We call them flags that kind of change the way it functions in a more subtle way. So I showed you ls before, just lists all the files and folders in this directory, but this doesn't actually show me everything that's in this directory. So if I want to see everything, I'm going to type ls, and then I'll type a dash. This lets me add flags, and then a. The a flag stands for all. So this is going to show me all the files and folders in this directory. So now there's a whole bunch of extra stuff we can see. In particular, any file or folder that starts with a period is a hidden folder or a hidden file. Normally, it doesn't show up. If you're using the Finder, you won't see these normally. But as programmers, we need to be aware of these and work with them. And this is one way you can see them, is with ls-a. So you might have noticed also inside of this folder, there are two items at the very top here, the dot and the dot dot. So those are not actual files or folders, but those are kind of shortcuts, I guess. Inside of every folder, there's this one shortcut dot that refers to the current folder, and then dot dot refers to the parent folder above it. All right. So let's see, here we are. If I pwd, I'm in /user/Rafael Sirota. So now let's say if I try to type cd dot, it's going to be your first pop quiz. What do we think is going to happen when I type this command? Where is that going to take me? Anybody want to just raise your hand?
It's not going to move. You're going to just stay the same directory you're at.
Right. So that command does exactly nothing. I do pwd again. I'm still in the exact same folder. It's a really unproductive command. You'll never see me type it again, but I just want to test your comprehension here. So something much more commonly used, cd dot dot, this is going to take me out of my current folder and up one level into the parent folder. So I'm in users Rafael Sirota right now. I do cd dot dot, and pwd. Now I'm just in /users. Now also you can combine these. So if I want to go up two levels at once, I could do something like cd dot dot. So that's the folder above Git intro, the Quebec folder, but that folder also has a dot dot inside of it. So I can go up two levels at once, or even go up three levels at once. So cd dot dot /dot dot /dot dot takes me up three folders into users Rafael Sirota code. All right, so now let's try making a folder, because you're going to need a place to put all of your projects. So I'm going to make a folder. We'll just call it projects. I use the command mkdir, that's make directory. So now if I ls, I can see my projects folder right next to that Git intro folder. All right, so I'm going to go inside my projects folder. Now I'm going to create a file in here. Oftentimes you'll create files at the command line and then you'll edit them in your editor later. We can create files using the touch command. So I say touch test.txt, ls, and I can see that file inside this current folder, test.txt. It's an empty file right now. I haven't added any text to it. So if I try reading it, I just get a blank screen, but that's fine. I've made a file at the command line, which I can edit later. Sometimes you might need to copy files. We can do that with the cp command, which is copy. Does what it sounds like. So to use cp, we'll give it two arguments. First is the file that we want to copy, say test.txt. And then the second argument is the name of the new file that we want to create. So I'll call it test2.txt because I'm feeling very creative today. So now when I ls again inside of my projects folder, you can see that I've got both of those files. So the cp command can also be used on folders, but it's going to work a little bit differently. So if I just try to copy the projects folder, it's going to give me this error message. Projects is a directory, not copied. Copy only copies one thing at a time. If you want it to actually copy a folder, we have to tell it to work recursively, which means copy the folder and then the subfolders inside of it, and then the subfolders inside of those subfolders, etc. So we do that with a flag -r. I say cp-r for recursive projects 2. Okay. So that's how we can copy folders. All right, so now if I look inside of these two projects folders, ls projects, I've got test2, ls projects 2. It's got the same files inside of it because I just copied the whole folder recursively. Great. But honestly, I don't really need two projects folders. So I'm going to delete my second projects folder. Now, if I want to just delete one file at a time, I can use the rm command. That's for remove. Let's say I rm test2.txt. Now, if we ls, the file is gone. But I already said I want to delete the whole folder. I'm not going to delete all the files individually. So I'm actually going to delete the entire folder with rm in the same way that I copied an entire folder with cp. So we're going to rm-r projects. Okay, so that recursively deleted the projects folder and then all the files inside of it, and then folders inside of subfolders or whatever, because it works recursively. Now I only have my projects 2 folder. All right. So now you can delete things. Okay, but now I don't like that I have this folder called projects2 because I don't have a folder called projects. So it's kind of weird that this one has a 2 when it's the only one. So I'm going to rename this folder. So it's just called projects. Now, the way that we can do that is using a command called mv. Now, typically mv is used to move files or folders. That's why it is named mv. But you can also use this to rename things by just moving it into the same location with a different name. So I just mv projects2 to projects ls, and then I can see my changes have taken effect. I now just have one folder. It is called projects. Porfirio, question?
Thank you. How did it know to put projects in the same directory as projects too? Like if you wanted to put it in a different directory, what would the syntax be for that?
So because I didn't specify a directory in this case, it just assumes to do it in the current directory that I'm at. There are other ways that you can specify paths. So if I give a path that starts with a slash, then that's an absolute path. And that refers to a specific part on my machine, and it's not relative to where I am when I run the command. So if I say /users / Raphael Sirota or whatever, this path that refers to that same folder no matter where I run the command from. If I say cd /users / Raphael Sirota, that works the same way no matter where I run that command from. Whereas something like cd .. that's going to be relative to my current folder. So if I wanted to move the projects out of the current folder, I could mv projects to .. projects, and then that would put it up one level. I can just do it based on an absolute path, /users / Raphael Sirota / code, I guess, put it somewhere else. And then this is an absolute path because it starts with a slash. So I can run this command and this path can be read the same no matter where I run the command from. Although projects is relative. So this is referring to a projects folder inside of my current directory from where I ran this command. So the location where you're at when you run the command is important, unless you use an absolute path. Does that help?
Yeah, thank you.
Cool. All right. So let's look at these files. There's nothing in them. That's kind of boring. I'm going to add some text to them really quick. Okay, great. So I just made a text file there. Now, sometimes you might want to just really quickly read a file at the command line. You don't want to go to all the trouble of opening up your editor, just read a 1 or 2 line file, something really quick. So there's a program you can use at the command line called less that lets you read files. So I less test.txt. It shows up here in my command line. And when I'm done with that, I can press Q. I'm actually going to make this a little bit bigger. Okay, so now this text file is actually several pages long because I want to show you if you're reading a very long file in less, you can use the arrow keys to scroll down, but more usefully, you can use spacebar to scroll a page at a time, and then the B button to scroll backwards a page at a time. So you should be able to, read through lots of files pretty quickly like this if you're just looking for information on your machine. All right. Now, some of you might be wondering why this program is called less. Up until this point, all the commands that I've taught you have more or less done what it sounds like they do based on their name. This one's a little bit weirder. So just a quick history lesson. There used to be a command line program called more. Actually, I think it still exists if you want to use it, but it was another command line program for reading files. And the idea was, you type more and it shows you the first page of the file, and then you just keep pressing more, and it shows you more of the file. There was a problem with more, apparently, that it could only read forwards. It couldn't go backwards. So if you, accidentally skipped a page too far, you just had to start over reading that file at the beginning in order to see what you missed. So people wanted a version of more that could give them actually less instead of more. And there's also the whole play on words of, less is more, whatever. So people created less as an upgraded version of more. So today, the name probably doesn't make any sense if you're just starting learning to code today and you just encounter less. I know it's kind of a weird name, but I like it if I can make the names of things make sense to you so you can kind of remember, what things do, or at least enjoy the humor in these. So that's less. All right, I'm going to press Q, get out of there. All right, so I'm going to do one thing real quick that you don't need to understand. It's just going to set up the next part of this demo. Okay, so all I did there was change the permissions of the test file, the test.txt, so that no one can do anything with this file. There are permissions are kind of a complex topic in the command line, and we're not going to talk about that in depth today. We're going to get into that in our next command line lecture when we talk about more advanced things. But for now, just understand that I have modified this file so that nobody can do anything to it. So now if I try typing lest test.txt, I get this error message, permission denied. A common way that you might see this sometimes is with the phrase e-access, just means error access. You don't have permission to access whatever you're trying to access. So this specific phrase, word, you might see this occasionally. That means there's a permission problem. And so if you encounter something like this, the simple way that you get around it is with Sudo. So this is a command that lets us pretend to be an administrator very briefly. So I guess for a little bit of backup or a little bit of background, in any Linux system, there is one user who is the root user who has permission to do anything at any time. Now, typically, you never log in as the root user because that's really dangerous. You could just, accidentally press the wrong key commands and then just delete your entire hard drive. So we log in as unprivileged users, and we can use the special command to briefly give us the powers of the root user for just one command at a time when we're being extra mindful and careful of what we're doing. So if I want to briefly pretend that I'm the root user and then just do anything I want with my system, I just prefix that command with sudo, which stands for super user do. So it's sudo, not sudo, very commonly mispronounced. So back over to my terminal here, I try to less test.txt, gives me this permission denied error. If I try it again with sudo, it asks me for my password. I type it in, and then it runs the command successfully, where I can view the file, even though I shouldn't have permissions to do this. So this will probably come up if it hasn't already for you during this course. You might need to install something globally on your machine in a location where your user account doesn't really have permissions for. So you'll have to use sudo to gain full access to your system briefly to install things properly. Let's see, for a graphical representation of how this command works, I'll show you this comic really quickly. This is roughly the flow of getting a permission error and then using sudo to make it do what you want. All right, so now there's one more command that I want you to be aware of. I'm not going to go in depth on this at all, but I would like to briefly introduce Vim. So I don't know if any of you have heard of this before. Vim is a command line text editor. You can use it for doing all kinds of development, writing full programs right at the command line. I do that sometimes, but I'm not going to encourage you all to do it in this class because Vim is a little bit tricky to learn, and maybe at this point it's not what you need to be focusing your efforts on. But the reason why I mention it is because it's possibly the default editor for your command line, and there are some other reasons why you might find yourself accidentally in Vim. So I want you to know enough about Vim that you can at least get out of it, because it's actually a very common problem that people open Vim accidentally and then get stuck in it and then can't quit. So if I type Vim, it opens Vim. This is my command line text editor. Now, Vim is a modal editor. That means it has multiple modes. So the one you would probably be most familiar with is insert mode, which lets you type letters and then they appear on the screen. Which is generally how you would expect a text editor to work. So here's me inserting text using Vim, great. There's normal mode, where every key on the keyboard does a command, like copy or paste, cut, moving the cursor around, that kind of thing. So to get into normal mode, we press escape. So I don't think you can actually see the difference on my screen, but just trust me that when I press escape, it takes me to normal mode. If you're not sure, you can just press escape like 3 or 4 times. And then from normal mode, you can press a colon, and that gets you to EX mode. Where we can type yet more commands, such as saving and quitting. So here in my editor, I typed escape, then I type colon. And so now you can see at the bottom of the screen, there's that colon, and I can type EX commands that will let me quit out of Vim. So there are only 2 commands that I need you to know here. WQ is write and quit. Quit. Also known as save and quit. And then Q exclamation mark is quit without saving. So if you ever find yourself in Vim and you're like, what the heck is going on? This is not where I wanted to be. I hit escape a few times, hit colon, Q, exclamation mark, and then it quits out without saving. Hopefully you will not find yourself stuck in Vim, but if that happens to you, you know what to do. Or you can just Google for it, because people before you have asked this question. And in fact, it's one of the most highly rated questions on Stack Overflow, just how do I quit Vim? This guy got 4,500 points just from answering that, which I think is kind of amazing. Yeah, so that is all the command line skills that I think you'll need to get started with this program. There's still a bit that I want to teach you about Git, but I think this would be a good time to take a break before we dive into that. But actually, before we take a break, does anyone have any questions about the commands that I showed us so far?
Like, Porphy, you have your hand up?
Yeah, I just wanted to, I was trying out the less thing, and it gave me just like a whole space full of what are they called, Tyndalls? What are the little wave one? And it was, I figured out it was just because the file didn't have anything in it, and I didn't save when I was writing it. So just in case somebody gets that, you know, just a heads up.
Good to know. You're saying you tried to read an empty file? Maybe if you're trying to read I'm sorry, what type of file were you trying to read?
It was a test file, the test.txt that I created. I was just following along with you.
Oh,
But go ahead.
I would expect you'd see an empty screen if you're trying to read an empty file. Like this is
Okay,
what I get.
I might have put, so hit enter on that, see maybe that's what I did.
Oh,
Yeah, I must have hit enter on it.
I don't know what that does.
No
But
idea.
Q still gets you out.
Yep.
Yeah, less might have other features I'm not aware of. I mostly just use it for reading forwards and backwards. Cool, so that was interesting. Any other questions?
Rafael, it's a quick question.
Mhm.
Might be like a basic question. So for the -R flag, does it matter? Is it in uppercase or lowercase at all?
It does matter.
It does.
Yeah, so in this case, it did need to be in lowercase. One kind of unfortunate thing about the command line is that many of these programs are not like standardized. You might use another command line program that also lets you pass in -R, but it would use a capital R for like no reason. So just read the documentation so you know what's expected.
Okay, thank you.
I saw another hand. I forgot who it belonged to.
Well, that was me. I was wondering about the lockouts on the file. So the 000 and then it's the file name itself, correct?
Yeah, when I was changing the permissions.
Yeah. Does that also work on folders?
It does, but the permissions mean slightly different things on a file versus a folder. Like executing a folder means different things than executing a file, but they both have an execute permission that you can set. If that makes sense.
Thank you.
Other questions?
Yeah, I had a question. So where yours says on the terminal, it says dash bash, mine says dash ZSH. And
Yep.
I was following along, I didn't want to interrupt, and everything works the same. Just some things look different, but is that gonna be an issue?
I don't think it should be an issue. So some of you, depending on the machine you're using, might actually not have bash as your default shell language. You might be using something else that is very similar called ZSH. Some people prefer it for some reason. They think it's a little more comfortable or convenient. I honestly, off the top of my head, could not tell you any difference between the two of them, other than the fact that your startup file for ZSH is called ZSHRC, whereas for bash, it's called bash profile or bashrc. They're like 99% the same. I expect most of you will get through this entire boot camp without learning any differences between them.
Thank you.
Yep. Joe, you have your hand up?
Sorry, I forgot to take it down.
No worries. Are there other questions?
No, I don't have any.
I feel like I saw a bunch of hands. Questions going once, going twice. Okay, so let's take a 10-minute break now. It's 1:45. So let's come back at 1:55, and I'm going to show you all how to use Git. All right, hope we're ready to get started again. I'm going to show you a brief introduction to Git. Now, as many of you may already know, Git is a command line tool that we'll be using to track changes to our projects. So a project that is tracked by Git is known as a Git repository. Now note that this is different from GitHub, which is a website where you can store and share Git repositories with other people. I know this is a common source of confusion, so I just want to clear this up. Now, before I just start running commands and showing you how Git works, there's just a little bit of background I want to explain about how Git works. So, of course, we're starting out with our project, our files and our folders. And what we want to do is create commits. A commit in Git is like a snapshot of our project at a particular moment in time. So in Git terminology, our files and folders, this is our working directory, or work dir, as Git will sometimes refer to it. Now, what we typically want to do with Git is make a snapshot of our working directory and create a Git commit out of it. So that's really what we want to do is, this is kind of our new way of saving our work. Whenever you do something you don't want to repeat, you're going to create a commit. So that way you have a snapshot in the past that you can go back to in case you've messed things up. Now, unfortunately, we cannot just directly create commits from our working directory, but there is a step in the middle. There's a place where we have to add our files. You can only create commits from your staged files, files that have been added to the staging area. So before we can create a commit, add files from our work dir to the staging area. So first we can add our files to the staging area, and then we can create a commit from all of our staged files. So if you want kind of a metaphor of why this is necessary, I like to think of Git as kind of being like a photocopier, where your working directory is all the original documents that you want to copy. And then the commits would be the black and white copies that you want to get out of the copier. But there's this step in the middle where you have to actually load the documents into the copier. So the staging area is kind of that phase of loading your documents into the copier, choosing what you want to be copied. Now, it's kind of an imperfect metaphor because technically a Git commit isn't a full copy of your repository. It just tracks the changes from the previous commit. So that means it's smarter than you think. It doesn't actually take up very much space for it to track all these different versions of your project. It's very smart. But I think that that photocopier metaphor should help you understand and remember that there's this intermediate area where we have to add our files before we can just create a commit. So that's enough conversation. Let me just show you how this works here. I'm just going to make a new folder. Call this Git demo. Okay, go into my Git demo folder, ls, there's nothing, ls-a. This is really empty, so I just want you to all see, starting out from scratch, completely empty folder here. I'm going to show you the first Git command we're going to learn. Let me just clear my screen, make that a little easier to learn, easier to see. First Git command we're going to learn is Git Status. If you have no idea what's going on with your Git repository, just ask and Git will tell you. So in this case, this isn't a Git repository at all, and that's what Git is telling me. Okay, so now let's actually create a Git repository. So I'll start an empty repository with just git init, that's git initialize. It gives me some warnings. I'm just going to ignore these for now. It doesn't matter too much. So now, if I type git status, it shows me something. There's nothing very interesting. I have no commits yet, but it tells me I'm on branch master. It tells me there's nothing to commit because I haven't created any files yet. I haven't added anything to the staging area. So at least Git is now aware of that I have nothing. It is an empty Git repository. So if you're wondering, what did I actually do when I ran git init? What did I create? Well, let's just look again in this folder. ls shows us nothing, but ls-a shows us this folder here called .git. So everything that makes this a Git repository is stored inside this .git folder. This is what tracks all the versions and has some other interesting functionality inside it too. If you want, you can even look inside of it. I'm going to ls.git, and it shows me it's got these other files and folders in there. You don't really have to worry about those for right now. That's kind of the internals of Git, how it works under the hood. You might at some point find some of these folders useful. I use the hooks sometimes. But at this point, I just want you to know that there is stuff in there and that this is what makes it a Git repository. So if I were to just delete that folder, rm-rf.git, and now I run git status, it is again not a Git repository. I've deleted the only thing that made this folder a Git repo, and so now it's just a regular folder again. So I'm going to, again, create a Git repository with git init, initialize an empty repository. And then I'm going to create a file. So there's nothing here. We're going to touch work.txt. Now we do a git status again. So now I get a slightly different message from Git. I still don't have any commits, but now I have untracked files. So it sees that there's a file in my working directory that does not exist in the commit history. So this is most of what Git does, what Git status does. It's just about moving and comparing files between your working directory, the commit history, and the staging area. So this is saying that we've got work.txt in our working directory, but it's not in the staging area and it's not in the commit history. So I'm going to add this file to the staging area. The way we do that is with Git Add. Now, I can specify exactly which file I want to add to the staging area. I could say git add work.txt, but most commonly, I want to add the entire project. I want to stage all of my files and make a commit that includes the entire project. So can anyone remember how can I refer to this entire folder right here in this command? This is something I've already told you today.
Well, wouldn't it be git add dot?
So
Yes.
they'll probably do the same for you, but like Lisa.
So git add dot will add the entire folder and then all the files inside of it all at once. So I don't have to deal with adding individual files and then maybe forgetting something accidentally. So I do git add dot. And of course, it doesn't tell me anything. So if I want to know what's up, I type git status again. And so now it's telling me that I have changes to be committed. So I've got this file staged, it's loaded in the photocopier, so to speak. So I can create a commit with my changes to be committed. All right, so now I'm going to use git commit, but it's important when you do git commit that you add the flag -m. This stands for message. And then in quotation marks, I'm going to put a message that describes the work I did. So ideally, when you're working on a complex project with many developers, all of your commits should have meaningful messages that describe what you did, so that if something goes wrong, you need to look back in time and see, when did this bug get introduced, what were we doing, and all these different commits. The commit message should give you a quick hint about what's happening in that commit and where you should be looking for the changes you're trying to find. Now, I want to remind you again, the commit message is mandatory. You need a commit message for every commit. If you try to run git commit without the -m flag, Git will open Vim because you need to type a message. So that is probably the first and most common way that you can accidentally find yourself in Vim, is by typing git commit without a -m. So if you don't want to type your commit messages in Vim, or you don't want to set up a different editor for Git, you can just add the message right here at the command line. Okay. So now I've created one commit, but now how do I look at my commits? If I do git status, doesn't show me anything about my commits. It just shows me that there's nothing in the staging area and there aren't any new files in my working directory. So if I want to look at the commits, I can do that with Git Log. Let me just clear my screen again real quick. So Git Log is going to show you all of the commits from your current commit all the way back in time to the first one in the repo. So this repo only has one commit, so we're only seeing one here, but still you should see some pretty interesting information. Here's that commit message I wrote. Here's the date and the author. And here is a commit ID. So every commit has an ID, so you can refer to it unambiguously. Sometimes you'll need to compare one commit to another, and this is one way you can refer to them. They've all got this ID. Commits also have a variety of labels attached to them, or tags you can call them. So for one, this commit is also head, which means it's the most recent commit and it's my current commit. It's the one that I'm working on right now. And we'll learn a little bit about branches later on. Right now, you only have one branch that you're working with. That's the master branch, but that forms another label. So the most recent commit on the master branch also gets this label master. So for now, while we're only working on one branch, odds are that head and master are always going to refer to the same commit. So to make the log a little bit more interesting, I'm going to do some more work here. Git status. So now I've got this untracked file, more work.txt. Git add dot. More work. Oh, I didn't close my quotation marks properly. Okay, there we go. So now I've done 2 commits. Clear that again. So now if I do git log, I can see both of my commits show up. So just for fun, I'm going to do a third one here. Okay, so I want to show you now. Let's just imagine that my terminal is much smaller than it is. If I do git log, now there's not enough room for my whole commit history to appear in my terminal because I've got 3 commits and there's only like 5 lines in my terminal. So my command line has opened less for me. Remember that program that I showed you about, 20, 30 minutes ago or whatever? So I can use spacebar to scroll through my commit history and press B to scroll backwards page by page through my commit history, or just use the arrow keys. So inevitably at some point, you'll be working on a Git project that has more than 3 commits in it. So you'll need to know that Git log opens less, and then you can use those skills to navigate through your commit history like that. All right, so that's about as much as we're going to learn for using Git on your local machine, but there's still more we need to learn in terms of getting your repository onto GitHub and then, well, not yet sharing it with other people, but at least putting it up in GitHub so it's safe and secure in case your computer explodes or something. So to do that, we have to work with remote repositories. So a remote repository is kind of like imagine, a remote island. It just means it's far away. It's somewhere else. A remote repository is a copy of your repository, but it's not on your local machine. It's on some other machine. So in this case, GitHub is most likely going to be your remote. GitHub is going to be hosting copies of your repositories. So before I can push this Git repo up to GitHub, I need to go to GitHub and make a repository there. So I'll show you how to do that real quick. I press this plus button on the top right, click new repository. I'm gonna call it Git demo. Git demo again. Great. We're gonna make this public because I'm really proud of my work. I want to show it off to everybody. I'm not going to bother with any of these initialization options, just creating a perfectly blank, empty repo. Great. So it's giving me some tips in case I have no idea what I'm doing, but I've done this before. So all I need here is to copy this URL. So this is the location of my Git repo. It's at github.com/my username/the repo name.git. So I copied that. Now I need to add a remote using the command git remote add. This is basically just telling my local Git that there's this other URL that you should consider a copy of the local repository. Then I'm going to try to synchronize them sometimes. So git remote. Now there's a lot of things we can do with remotes. Here we're adding a remote. So git remote add. And now there's two more arguments that git remote add needs. So it needs the name of the remote. So this is just a nickname or an alias. You can call it anything you want, but it is strongly conventional that you call it origin. Like literally every time anyone makes a Git repo, the first remote is always called origin. Please don't get too creative with this. And then the second argument is going to be the actual URL of the remote repository. So I just paste that in there. So basically all this is saying is that, in the future, I'm going to be doing some work with this remote at github.com, but I don't want to type in this full URL every time I'm working with it. I want to have a short nickname I can use. And so I'm going to make that origin. So I add this remote. All right, so if I want to double check what I just did, I'll do git remote. So that just tells me I have a remote called origin, which is not super useful. Let's try git remote -v. -v is for verbose, basically just means tell me more, be louder. And so here it's telling me, okay, I have a remote called origin at this URL, and I can fetch updates from it, and I can push updates to it. Most importantly is just double checking that this URL is correct. Sometimes I add a remote and I mistype it, but then if you have a typo in the URL, none of your other git push and pull commands are going to work because you're trying to contact a URL that doesn't exist. So if you just want to make sure you typed it in right, git remote -v will show you what the remote is. So if it turns out that I actually messed that up, I put the remote in with the wrong name. I can remove it, git remote rm, and then the name of it. So git remote rm origin. Now, if I git remote -v, I have nothing because I deleted my only remote. So I'm going to add it back again. Let's just go back up here. Yeah, git remote add origin, this guy. Just pressed up a few times to go back to my previous commands. And so now I'm going to run another git status. Okay, so I just wanted to make sure that I don't have any uncommitted changes. All the work that I've done recently has been saved, it's been added, it's committed. And now I want to update it on GitHub, which currently there's nothing here. Just refresh the page, nothing at all. So I'm going to push it. Git push. That's the command for taking my local code and then updating a remote repository somewhere else. And then I have to specify the name of the remote I'm updating and then which branch I'm updating. For right now, we only have one branch, so it's git push origin master. And I get to see it working. If this was a bigger project, it would probably have a status bar that goes across the screen as it's taking its time, but this was a very small repo, so it uploaded very fast. So you can see I've got a new branch. It updated master on the remote with master from my local repo. So now if I go back to GitHub and refresh the page, we can see my repository that I was working on locally has now been backed up to GitHub. So now the opposite of push, if you want to get new changes from the remote repository and apply them to your local machine, the opposite of push is pull. And so pull is the command we'll use to get changes from the remote. So this could be like if you are working on a project on multiple different machines. So, when you're done with one computer, you push it up to GitHub, and then on the other computer, you pull it down. Or maybe when you're working on group projects with other people, you'll be pushing and pulling on GitHub. Before you start working, you'll want to pull from GitHub to make sure that you're working with the most up-to-date version. So I'll show you how that works here. So I'm just going to edit one of these files from github.com. I'm going to pretend that this is from a collaborator. That's not from me. So I just save that on GitHub. So now the repo on GitHub has newer changes than what I have locally. So let's see if I try. So now I just did some more work locally. If I try to push this, it gives me an error. I can't do that because there are changes that are on GitHub that I don't have locally, but I also have changes that GitHub doesn't have. So there's too many differences. GitHub won't automatically figure out the differences on their end. So I have to deal with this on my end. So first I'm going to do a git pull and get the changes that I added on GitHub. A collaborator added this text. So yeah, if I look at work3.txt, it's currently empty. Do git pull, origin master. It did do the pull successfully. It's creating a commit, and it wants me, so this just opened Vim because it wants me to edit this commit message. I think it's fine as is, just merge master. So I'm just going to press :WQ, and then when I save this file, that finishes the commit. So now you can see it did a merge. We'll tell you more later what this means in depth. Here you can see work3.txt, 1 with the green plus. That means there was one line of text added in the code that I just pulled. So now if I do less work3.txt, now I can see that one line of text that was added on GitHub. It's been pulled down to my local version of the repository. Right, so now that I've gotten all the changes from GitHub on my local machine, now I can push my changes back up to GitHub. All right, so that's how you'll work on repos that you start from scratch, like your personal projects. But for the exercises that you'll be doing in Code Platoon, we already have some starter code for you and some instructions. So you're not going to be creating those repositories from scratch. There's a slightly different flow you're going to use. I'll show you how you can do that. All right, so I just went to the repo for tonight's first exercise, algo 99 bottles. You're gonna basically write a little program that prints out this algorithmically. It's super fun, you're gonna love it. But so the first problem is that this repo here, algo 99 bottles, this is not in my GitHub account. This is in Quebec Platoon's GitHub account, which belongs to Code Platoon. So the first thing I need to do is copy this into my GitHub account, and that's called forking. So I just click this fork button in the top right. We should fork algo 99 bottles to Raphael Code Platoon. And get to watch this spin for a second. Okay, so now, if you look in the top left, we're in Raphael code platoon / algo 99 bottles forked from this other repo. All right, so forking, again, this is a GitHub concept. This isn't native to Git itself. This only exists on the internet on GitHub. This is for copying a repository from one GitHub account to another. But now that I have this in my GitHub account, I can clone it. Cloning is the command for copying a repo from GitHub to your local machine. So again, I've copied this URL here, the clone URL. And you get outside of this Git repository that I'm in. And I'll type git clone, and then I'll just paste in the repo URL, ls, and there's the repo there, algo 99 bottles, cd into it. And these are the 3 same files that were over here, except that it's not connected to Code Platoon's GitHub account. It's connected to my GitHub account because I forked it before I cloned it. All right, and then I can start working on the exercise. I'll open my editor here with code dot, opens this whole folder in Visual Studio Code. Work. And I go through the motions again. Git add, well, let's just do status first, just for fun. I like running Git status. So yep, I modified 99bottles.js, Git add dot, Git commit -m. I did work. Git push, origin master. And then you can see it here up on my GitHub account. All that work that I just did has been updated to my GitHub account. So if my computer just spontaneously bursts into flames, like no worries, my work has been saved here. It's safe and sound. Also, if I type git remote -v, you'll notice that the remote is already set up. I didn't have to add the remote explicitly. It's just assumed after you clone a repository that you're going to want to push and pull from the same URL that you cloned from. So Git automatically sets that up as a remote for you. But it's good to know how to check it and inspect it to confirm that it is what you think it should be. But yeah, so that's the basics of Git. You should now know enough to get started on the exercises. Are there any questions about today's lecture? Everyone just understands Git on the first try? Y'all are real smart.
No, so go ahead.
Oh, so could we go over just the last steps again? So right after you changed your 99 bottles JS file, so you went through, you did your commands, then back on the command or the terminal were git add period.
Right. So I'm going to make another change real quick. There, so I did some work. So yeah, I have unstaged changes, and if you do Git status, it even gives you clues.
Okay.
So, you know, try Git add to say what will be committed. Well, Git add dot, want to add everything. I said dot. Git status, another clue, changes to be committed. Committing is my next step now. So I will git commit -m. And so now if I want to update the remote repository, the last thing is git push origin master. So, you know, there's a handful of commands that you'll run when you set up a project and if you run into trouble and you're debugging. But when things are going well and you're in the groove, there's really 3 commands that you'll be running over and over and over, being git add dot, git commit -m, commit message, git push origin master. And if you're working with other people, you should start out with a pull just to make sure that you're not starting out with an out-of-date version of it. So a hand up.
Yeah, so I was following along and at the part where I added the algo 99 bottles to my Git, I accidentally copied the URL for the code platoon, not the one I forked.
Wait, so you did fork algo 99
forked-
to, okay.
So I forked it, but when I was copying the where you go to code and then copy, I accidentally got the one that wasn't forked.
Okay. I mean, you can delete the remote with git remote rm and then add the correct remote, or you can just delete the entire repository and then clone the correct one.
Okay, so you say with git remote rm and then the algo 99.
You want to delete the remote, so just git remote rm origin should be the command.
Okay.
And then git remote add origin with the correct URL.
Okay, thank you.
You're welcome. Any other questions?
I had a question just about Git overall. So it's kind of more like a theoretical question about like the version control of Git. So can you go back at any time to like a previous version if you like push something that's like messed up?
Yes, that is a large part of the reason why we use Git. It just happens all the time that, you know, big company pushes out some update and it seemed like it was good in testing, but then when you actually deploy it live, everything is broken. And it's not fast enough to fix all the problems like in real time. So the quickest thing is just roll back to the previous version. And so you can use Git really easily to go back to the last version you know was working. And then the engineers can figure out the actual bugs on their own time.
So to build on that question, if I guess I'm trying to wrap my head around the functionality of using Git only on your local device. If I'm going to save a file after working on it, if I don't commit it, does it not like permanently save that file? Do I have to commit it to permanently save it? Or I guess, how does that work between saving it and committing it locally?
Right, you need to commit your project in order to have Git permanently remember the state of your project. However it was at that moment in time. So yeah, generally speaking, anytime you do work that you don't want to repeat, or anytime that your project is in a stable state, and it's like not actively crashing and buggy, you should probably commit and push to GitHub. Just as a general rule.
Just to clarify, like just the process you went through, we'll go to the Code Platoon website, go to this day's lecture. When we fork it, we make a copy of the Code Platoon thing to ours right away, right? With no connection, as in I can start messing with the files and it won't start messing with the ones on Code Platoons.
Correct.
Okay. And then the clone thing just brings it to my desktop from the remote area. So that's
Correct.
local. Okay.
That's right.
And I want to add on to that question.
Mhm.
So if I started coding on VS Code and it wasn't on GitHub, the way I would get it to GitHub is the git remote add origin URL.
Yeah.
Okay, cool.
You'd have to create a remote repository on github.com to get the URL, but then you'd run that command you just said at your local machine.
Okay, awesome. Got it.
Cool.
Is there a question? Is there a way to do the add the repository not on the website, but from your terminal?
Say it again.
Is there a way to add the repository not on like github.com, but like a command on your terminal?
Add a remote, you're saying?
Yeah.
The only way that we can add remotes to a repository is locally at the command line with the git remote add command. Not sure what you're referring to.
Because you're saying like to create the repository, we have to go on github.com, then click the create at the top.
Oh yeah.
Yeah, but isn't there a way to just do it straight from our terminal so that we skip a step like that? Or is it just made it so that we have to make it like on the website?
There might be. This is the conventional way to do it. I think there are extra tools that you can install on your machine. There's a Git CLI or a GitHub CLI that lets you do github.com kinds of things from your local machine, but that's not how I traditionally do things. So more commonly, people will set up their repository on GitHub and then connect to it from their local machine the way I showed you.
I had one more question. What does import repository do?
Where are you seeing that?
Import? You just had it when you clicked it too.
I've never clicked this button. I have no idea what it does.
Okay.
Let's try it. I'm guessing it takes repos from other version control systems and puts them into GitHub. That's kind of weird. This is not something I've ever needed. Any Edgar, question?
Oh, no, sorry, I just forgot to put my hand down.
No worries. All right, any other questions? Going once, going twice. Okay.
Yes, I have a question real quick.
Let's hear it.
Whenever I try to push to the repository, I get a message with a path to something in my program file saying git-credential-manager-core.exe is not found.
It's something with your password settings. You need somehow or another, you need Git to know your password for GitHub so it can authenticate you. And it seems like that might have not been set up quite correctly. I'm not sure offhand what the issue is, but if you reach out to one of the TAs, they should be able to help you get set up straight.
Okay, thank you.
When I do Git status, it brings up like a whole laundry list of files, like everything from my ZSHRC files to like my OneDrive and all sorts of stuff. Is that supposed to happen, or is there a way for me to get rid of all those?
That's not supposed to happen. Probably what happened is that you created a Git repository somewhere that was not an empty folder. So here, let me share again. So, for this demo, I was using, what is it? Yeah, this empty Git demo folder. I was creating a Git repository in there. If I just create a Git repo like here, in this folder that already has a whole bunch of stuff in it.
Okay.
And now I do Git status.
Okay.
It's going to tell me everything that was already in there is an untracked file in this Git repo. And that's a pretty quick clue to me that I created a Git repository somewhere that I did not mean to.
Okay, cool, thank you.
So I'm just going to delete this. Cool. Any other questions? Going once, going twice. This is, I think, pretty important stuff. So please feel free to ask whatever's on your mind if you're confused. Sukhdev?
Yeah, one quick question. If our challenge one, for instance, are you going to code and how that's do the add?
I'm sorry, I'm having a really hard time hearing you. Your microphone is a little bit choppy. Can you try that again?
Can you hear me now?
It's a little better, yeah.
Okay. Basically, the VS Code as far as saving and the adding commit, that's going to be once we push that, how that works. Word it here. So let's say code, open up the file, I'm in VS Code, I'm working on the files, for instance, and I want to commit it. I'll add, it'll go to the and then we have to upload it or push it to the GitHub. Is that correct on our end?
I want to say yes, but honestly, your connection is kind of shaky right now. I want to say I heard like half of what you said. Maybe you could try slacking me after the lecture and I'll be able to help you out a little better. Sorry. All right, so if we don't have any more questions for right now, why don't we?
I have a question real quick.
Yeah, let's hear it.
Okay, so I did what you said with remove origin. However, when I go into right now I'm at Git demo and I hit ls, there's still something that says algo 99 bottles. So if I removed origin, why is that still there?
So that removes the connection to the remote repository, but it doesn't change any of the files that you have locally.
Okay, so is there a way to, so for the algo 99 bottles, is there a way to remove that? And is that a directory or what is that?
There is definitely a way to remove that. Maybe we should take this offline though. We can probably work on this one-on-one after the lecture.
Okay, sounds good.
Yeah. For now, yep.
Hey, apologies to Dave here. Is it possible that visual code MD file that you're writing, I missed a couple of steps, but I'm pretty sure I can get there. Is it possible to upload that or actually show that while we're on a break so I can try to catch up?
This notes file you're saying?
Yes. Just from the Git initialize, because I skipped a step at the beginning, but I don't want to hold everybody up. Okay. Thank you.
Yeah, I can put it up here. I can also Slack this all out to you afterwards. And also, if you watch the video of this lecture afterwards, you can see me writing the notes again.
Thank you.
But yeah, you should definitely expect to have access to these notes afterwards in whatever format is useful. Any other questions? Going once, going twice. Okay, so let's take another quick break. It's 2:45. Let's come back at 2:55 And then Encore is going to give you some tips for using VS Code.
We have some settings that we're going to recommend. Now, you might be thinking, well, I want to customize mine and do things a little differently. You do have the liberty to do so. You change these. That's because when we're working on like pair programming exercises or just looking at someone else's screen, it's going to be good that we all have the same and consistent workspace and like formatting for everything. So it's easier just to read someone else's code, work with someone else's machine, and whatever else it might be that you're doing as a class. So we're going to apply these settings to our VS Code. To do that, I'm going to go to my VS Code window that I brought up. There's a couple ways to do this. You can go to the code menu if you're on a Mac. Again, if you're on Windows, it might look a little different, but you should be able to follow along. Go to preferences and settings. All right, so if you get to the settings window, I'm going to click that. You'll see something like this, which is one way you can set your settings. So you can go through, these features like the window, new window, configure whatever you want to. But there's also kind of an easier way to just modify the settings that you want. So if you look at the top right corner where my mouse is kind of circling, there's this like icon that says like flip your sheet to a JSON mode. So right now you're looking at like the UI, the typical window interface. If I click this, it's going to change and I'm going to see something that looks like this. All right, these are the same settings, but we're just kind of editing them in a different format. So I'm actually just going to delete all these because they're probably a little different than what I want them to be. I'm going to copy everything I have on the curriculum page. All right, so I'm just going to copy that. Again, if I'm going too fast, let me know. But copy that, and I'm going to paste that into my settings.json. That looks really tiny, so. Nathan, you have a question?
Yeah, where was that option to flip it to a JSON package? I missed that part.
Sure. So if you're in your settings, there should be this icon up here that lets you flip it. It looks like a page with like an arrow turning it.
Oh, gotcha. Thank you.
So that's one way to get to it. Just another shortcut for VS Code. VS Code has tons of shortcuts. Also, please make sure you mute yourself if you are not. Thank you. Yeah, so another way you can get to this on a Mac, you can hit Command, Shift, and P. That should bring up this menu, and then you could search for settings here. And notice it has open settings in JSON. So it's going to open that, and again, you get to the same place. But here, again, I copied all these settings, so that's what I want to use by default. Probably looks a little tiny. Okay, let me just save this. So save that. All right. So again, these are the settings we're setting. Again, we're not going to go through all of them, but this is essentially what all of us should be using. Some items I want to mention that are kind of handy. Whereas autosave. So right now, By default, this is not enabled, but we've just set it so that anytime you move your focus off the current page, it's going to automatically save that file. Now, this might sound annoying, but it's actually going to be really helpful because you're going to be constantly shifting between the VS Code editor and the terminal. You just want to save so that you're using the latest changes. Again, you can kind of go through this and kind of just understand what you set, but there's some tab size, font size, again, nothing too detailed going on here. All right, so once I have copy and pasted this, I'm going to hit Command S to save the settings, and then this should take effect. So I should be using these settings for any files that I open. Any questions about that?
One question.
Okay, yeah.
Thank you. The Windows zoom level, yours had 1 and our code thing says 0. Does that matter?
I think that's because I was trying to make it larger. So I think that might have just changed right here. Yeah, it shouldn't matter. I think it's when I hit like Command. Yeah, so I'm trying to zoom in just to make it easier to read. I think that's what's adding in. But yeah, no, that should not matter. Thanks for asking.
Thank you.
So are these like absolutely, you need to have these settings? Because, okay, cool. Just, yeah, a lot of stuff going on mine.
All right, yeah, these aren't absolutely necessary. Again, this is just to this is highly recommended so that all of us, we have 43 students here, we have TAs, we have instructors. All of us ideally should have the same setup so that it looks the same if I'm on, looking at Ivan's screen or looking at someone else's screen. It should be kind of consistent and we shouldn't have to deal with like weird formatting between our computers. But yeah, you don't need this to get anything kind of working. All right, so that's one thing. We just set our settings. We'll see those in effects shortly. Let's actually go back to the curriculum page. So that's the settings we set. One thing that makes VS Code really great are extensions. It's highly customizable. You can add a lot to it. So right out of the box, VS Code doesn't have all these extras in it, but it's really easy to get them in. So we have a few recommended extensions. Again, these aren't necessary to kind of do any development that we are going to do, but it's going to help you immensely. So for the most part, I'm just going to say definitely install these. So we're going to do these one by one. I already have them installed, but you guys can follow along here. So there's something called Beautify. In your VS Code on the left panel, there's a bunch of tabs you should see here. So the top one is the File Explorer, where you can see all your files that's in your workspace. If you go down to maybe like it should be the 6th, perhaps the 6th one, might be 5th. There should be something that looks like ice cubes coming together. That's the Extensions tab. So if you click that, you should be taken to a panel that shows you, installed. These are the extensions I've installed on in my VS Code. Most of you probably don't have many of these or any of them. But if you start searching for an extension like Beautify, right, it should find it. So I have something called Beautify. If you click on it, you get a good description of what it does. Again, you don't need to read through it. We're not installing viruses on your computer, but just understand that these are going to make your development just easier to handle. Right, so if you do want more of a detail, again, all of these extensions should have a good detail page. But if you want to install it, you just need to click this tiny blue button that says install. You can also go to this page. If I want to uninstall it, I can click uninstall, and then I just uninstalled it. Now, if I want to reinstall it, just click install. All right, so that's Beautify. I'm just going to go through this list so you guys can jump ahead if you want to, but VS Code icons. Again, this is just for visual benefit. It has nothing to do with development. But right now, if you look at my icons right here, they have different icons based on the file type. So if I added a new file, called it like run.py, notice that my icon has changed to a Python logo. Again, it seems minimal, but it's really, really beneficial when you have like a large project with tons of files. Kind of easy just to visually see what types of files you have rather than reading the file extension. Again, minor, but I really find it beneficial. So maybe you will too. Get rid of this file. Okay, so that's what VS Code icons are going to do. So if you go here, again, search for VS Code icons. That's what it was called. VS Code icons. Yep, that's what I've installed. So that's another extension. So again, all these are just configurations you're adding. You can find a ton more. So again, there's probably hundreds, maybe thousands of extensions that you can install. You might find some cool ones that might help you. So you are not limited just to these. Bracket pair polarizer, I use this one a lot, again, in my development. What this does is when you're typing, so if I go back to my code files, as you're typing, I added a bracket right here. It's going to match those kind of in pairs. So notice that these brackets are pink versus these are yellow. That just makes it easier to understand what level, what scope you're in. So now I know that this pink bracket matches with this bracket instead of matching with this yellow one. Now, obviously your tabbing, your code formatting should play a big role in identifying what scope you're in. But if I keep adding more brackets, well, this scope is here. And I just know that by looking at the color of the icon. Again, this is totally optional, but I like seeing kind of the matching brackets in color. Okay, let's just kind of keep it going. Hopefully you guys are following along. Any questions with these extensions? Path and IntelliSense. I'm not entirely sure what this does. I know IntelliSense is just aid for developers to kind of suggest what functions or variables you might want to use. Let's see what this does. Yep, auto completes file names. So this again just makes your life easier. Don't want it, you don't need to download it, but highly recommend it. Live server. This is one of my favorite ones just because it makes looking at HTML files really easy. So if I go back to extensions, search for live server. Again, most of these should be pretty quick to install. So I'm kind of zooming along here, but live server lets you view HTML files pretty easily. And as you make changes to your HTML file, it'll update the page. That's kind of nice. By default, that a browser would not do that. All right, a few more. Python. This will make your development in Python easier. So if you IntelliSense for Python, again, just makes it easier to understand and autofill things you're working on. Okay, the last two we're not going to really see today, but we're going to be doing something called pair programming twice a week. You guys are going to be getting to groups on Tuesday evenings or Tuesday afternoons and Thursday afternoons. We're going to go over pair programming tomorrow, so we might try to demo one of these tools. But obviously, most of us are in a virtual setting. LiveShare makes it sort of simpler to kind of work on the same window together, even though it might be 100 miles apart. So definitely install these two because you may use it. Again, you don't have to use it, but LiveShare it's kind of cool to use. We'll demo it tomorrow morning when we're working on a challenge. But make sure you install LiveShare and I guess LiveShare audio if you want to use VS Code to kind of chat. And you don't have to. We use Slack primarily for most of our communication. So you don't have to have these. All right, as I said, hundreds of other extensions you can add. Google cool ones. I'm sure there's a lot of cool ones out there that I've not discovered. But yeah, if you find a cool one, maybe recommend it to the class. But otherwise, yeah, this is what again makes VS Code really cool is that you can customize it, benefit off of someone else's development, and get kind of their cool features into your VS Code. Any questions about extensions? All right, I'm going to assume that you guys either got through this list or can get through this list on your own. But again, these are just recommend ones that we recommend, but there's tons more you can add. All right, so let's talk about VS Code. So again, we talked about the side panel here. So we have our file explorer. We talked about extensions. There's also a search, and I'm sure you guys have searched plenty of times. This will actually search through your entire project. So again, right now we only have like 2 real files. We might have hundreds of files. So the search can pick up. So I searched for the word find, and it shows me every occurrence, what line number they're on. So I could go to that line and see, okay, I found this line that has that matching sequence. Maybe that's the line I was looking for. There's a source tree control. So this is associated with Git. You can add some extensions that lets VS Code show some more Git related information. Right now, it's showing me an M here in VS Code. This M says I've modified this file. So again, it's using the Git history to know what the previous version was and that I've modified it. So you can kind of use this to keep track of, you have a visual, instead of using Git Status, you can kind of use this to see what you've done. So notice that it's showing me what the previous item was and what I've changed it to. So it looks like I deleted a comment, so that's why it's in red. So this was the original, and this is my modified changes that have not been committed to Git yet. All right, so this panel is really handy to kind of review your changes. If you made a mistake, you can kind of see, oh, I actually didn't mean to change this. Let me copy this, put this back here. And I think I need to tab it. All right, cool. So now I'm kind of restored. So now there should be no modifications if I save that. So notice that that file went away here. So I have no actual modifications. But if I did change something, so let's go back to main.js. Let's say new stuff here. So again, if I save this, I should see that back. Notice there's a 1 here. Yep, that's the change I made. So it highlights exactly what I changed. Nothing else is highlighted because that's all the same. All right, so definitely make use of this panel. Makes it good to kind of see what your Git project is looking like. There's many other Git extensions you can add in, so definitely don't be shy to add more extensions. There's a debug menu. We're going to talk about debugging. This is a skill that all of us developers need to develop and refine. So when you're starting off coding, debugging is probably at the back of your mind. You just want to get things working, but debugging is important, especially again with large projects. You got to be able to find issues efficiently. You don't want to read, if you have 100,000 lines of code, you're not going to read every single line each time something goes wrong. You need to understand how to narrow down your search and figure out exactly what's going wrong. So we'll talk about debugging briefly, use VS Code to kind of see how we can use VS Code's debugger. Okay, let's get to solving this challenge. Again, this challenge is meant to be introductory. The first thing is obviously read the README. So let's go back to, I think I should have multiple tabs here. All right, Quebec Platoon, we had day 1 example. I like reading it in the browser, just better formatted for me, but there's a README file. Most of your challenges should have a README file, so you could read through it. Let's take a look at what we need to do here. So this is a sample coding challenge. Your objective is to modify the code in main so that all the tests in main.test.js will pass. Important, you should not modify anything in main.test.js in order to get things to work. So it looks like we have a few things we need to implement. We need to implement a function called find first odd, find second odd, find first negative, and find second negative. All right, once you successfully have implemented things correctly, you should be able to use node to run main.test.js and verify that each test passes. So let's quickly do this. Again, it shouldn't take too long. So in VS Code, you can use the integrated terminal. So if you go to the terminal menu at the top and hit new terminal, that's going to bring up a window that is the same thing. Let me make that larger so we can read it or whatever. This is the same terminal that I'm using outside. So, you have iTerm probably that's running outside where you have access to your terminal. You can do things here. So I can, make a file here. So if I wanted to make a file, I could do touch new file.js. Notice I'm in my day 1 example folder and I touch, so the touch command creates a new file. So if I go back to my VS Code over here, notice that a new file was created. But instead of going to a separate terminal, VS Code has an integrated terminal right here. So I can do the same thing here. Let's say I want to create a new file. I could do touch new file 2.js, new file here. Now, something that, again, a lot of us might struggle with early, and it's something I struggled with, is why are we using the terminal when we could just use the UI here? Now, I kind of do both. I'll be honest. I don't always use a terminal, but the terminal can make things a lot quicker. That's the answer to why we developers use the terminal. It might seem slower at first because you're learning kind of like a new interface, but doing things in a terminal is much quicker most of the time than kind of clicking around on windows, finding menus and whatever else you need to do. So that's why I get comfortable with using the terminal. Don't try to shy away from it.
Hey,
Right.
I just want to add on a quick point about that real quick about things in the terminal being faster. If you're just doing something once, it might not be obvious just how much faster it is to use the terminal, but you can really see the benefits if you need to do something 1,000 times, or if you need to do something really reliably. Like if you have a set of 10 steps and you're clicking through the GUI and then you need to do that again next week, you might forget some of those steps. But if you put it all into a script, then those things are going to execute reliably exactly how you wrote them. And also, if you have like a whole folder and you need to apply some logic to every file in that folder, you can write a script that just loops through your folder and does that work to every file. So it's the same amount of effort to do it to 1,000 files as one, whereas in the GUI, you'd be clicking around a lot.
Yep, absolutely. Yeah, scripting is something, as Raphael mentioned, if you're doing something repeatedly as a user, write a script for it. Again, that's what developers kind of do for themselves to make tests easier. So again, we can use a terminal to create a file. You can use VS Code. So if you notice in the File Explorer, I want to create a new file here. Again, most of the time, I'll be honest, if I want to create one new file, I'll just do it here and say new file 3, I think I'm on, .js, and then I get another file. So again, many ways to do the same thing. You can do it from an external terminal, which I don't recommend. I recommend if you're in VS Code, just use the integrated terminal that's right there, or you could use some of the UI features in VS Code. All right, let me get rid of my new files because I actually don't want 3 new files. Delete those. All right, so we have this terminal. So most of our work is going to be in VS Code, where we edit stuff and then run things through the terminal. All right, so let's actually run our test file, because that's the first, that's eventually what we need to do, get working. So there's a main.test.js file in my day one example. To run it, I need to do node and then the file name. So main.test.js. Node is a program that runs JavaScript. So again, this file right here, this is just the file. It's nothing special. It's just a text file for the most part. But when we pass it to Node, Node is able to interpret this as JavaScript and will do the appropriate thing. We could open, a JS file in a text editor. It's not going to do anything. It just shows us what's in that file. So if I run node and then main.test.js, we should get some output. So we've made no changes right now, and this is what we get from the outputs. We have a few tests that we're running. Notice that we are failing pretty much all of our tests. Passed is false for all of these. Our goal here is to get all of these to be true. And the way we get that to be true is, let's take a look at what the test files are checking. So it looks like we're calling a function called find first odd, maybe a function called find first negative. So let's actually try to pass these test cases. So I'm going to actually comment out a lot of these because I just want to focus on them one by one. All right, so our logic, as mentioned, is going to be in main.js. So notice that we have some code coded for you, as in we have the functions that exist, but we actually need to solve these, solve this challenge by actually adding in some logic. So a lot of the challenges we might have some starter code for you. Some challenges you might have to do from scratch, but a lot of times we're going to have something in place for you where you can kind of get your bearings right. So for find first odd, if you look at the README, it's going to be a function that takes an array and returns the first value that is odd. Otherwise, should return a string that says not found. All right, should be simple enough to do. So I'm just going to get going here. We take in an array that's already done for us. I'm thinking probably use a for loop. So let's get a for loop going here. I'm going to start at 0. Index 0 is always where we start our arrays. And then we want to go maybe to the length non-inclusive. So again, the last index in our array is going to be array, the length of the array minus 1. So we don't want to go up to the length. We want to go less than that array. And then we're going to increment our I value. All right, so we need to find an odd value. So let me just code this up, see if we get something working. So to find an odd value, I'm going to create a variable to make this kind of really obvious here. So is odd. I'm going to take my candidate. So that's going to be array at index I. I'm going to mod that by 2. So if I mod it by 2, if there's a remainder, that means it's going to be odd. That's what I'm thinking. Again, I could be wrong here. So testing and trying out things is definitely something I need to do here. But I'm thinking if I take a number, try to divide it by 2 and get the remainder, that's what the mod operator is. If that is equal to 1, if the remainder of this operation is 1, then I know that is odd is going to be true. That's what I'm thinking. I could be wrong here, so we're going to test this out. But if I get something that is odd, I'm going to decide to return that value, because that is what the requirements told us to. Return the value, the first odd value we find in our array. However, if we don't find anything, as in we get through this entire for loop and we never found something that is odd, I'm going to return, I think they told us to return not found. All right, so that's my initial implementation. Again, it could be wrong, but I think it looks right to me. So I'm going to give my test case, my test file another run. So let's do up arrow, because that's the previous command I just ran. Or because there's 2 commands. So I'm going to do, let me actually clear my console so you guys can see this better. So if I do node main.test.js, notice that I'm now passing test 1. I got a true, the expected value was 5, and the actual value I got was 5. So let's take a look at our test case again. So this was a sample array. Let's find the first, let's, as humans, find the first odd value. So it's not 8, that's even. Negative 2 is even, 4 is even. Yep, 5 is the first odd number there. So it looks like that worked correctly. But let me actually, knowing with this program, what if I uncomment this line? So this is testing sample array 2, which is a little different. We're calling find first odd. So that's the function that's being called by our test case here. Let's run this. Let's see if we pass both our test cases for find first odd. I'm going to clear that, run this. All right, notice that we still pass our first test case. However, we are not passing the second test case. We got our actual value was not found, but it seems like we should have gotten -1. So let's take a look at our sample array. We have 8, that's even. Sorry, this tooltip keeps popping up. We got 2, that's even, 0, even, even. Yep, -1 is in fact in our array. It is the first odd number. So we should have been able to return it. So let's say I'm not sure why this is going wrong. Like I'm looking at it, my logic looks right. Well, obviously one part of debugging is just reading your code. But let's say I looked at my code, I'm like, I still don't get it. I don't know what's going wrong. Now, a popular thing we can do is adding some console logs. And I'm not saying this is not improper. Like I do a bunch of console logs all the time where I want to like, let's print out the value of is odd maybe, and print out the value of I. So this is the index, and maybe print out array at I. So let's do console logs. So a lot of debugging can be just done via console log. So I'm going to add that console log in there and then run my test file again. Let's take a look at what my output was for the second test case here. So notice right here is odd is false for a value of 8. So that's true. That's correct, right? 8's even number, so is odd should be false. But keep going. Yep, these are right. But notice it gets down to -1, and I still get a false. So obviously that's not what I expected because -1 should be an odd number. But this is via console log where I'm kind of just printing out the values. I'm going to show you how to use VS Code, just another way you can debug. And again, this is really useful, especially as your projects get more complex, to kind of see actually what's going on in your application step by step. So right here, I don't really see it step by step. I just see the output kind of thrown out together. But if I want to see it as it's going through this code, you can do that from VS Code. So right now we're using our terminal to execute our application. We can run our application through VS Code also. And the way to do that, if you go to the run menu, so go to the run menu, go to start debugging. So if you go to start debugging, it's going to give you a list. It's going to ask you, how do you actually want to run this file? Now, JavaScript can actually run through your browser, and that's something we're going to be doing later on in the cohort. But right now we're going to use Node. Node is a terminal, your terminal-based app. It's not going to use your browser, but I want to use node.js to run this. So if I click that, it's going to use that application. And it's actually going to run my current file, so that's not what I wanted. When I run my main.test.js, so it's going to start debugging Node.js. So notice in my output, I still got the same thing as I did before, but my VS Code actually ran this through the debugger. So the reason that's beneficial is because you can add breakpoints. So if I'm looking at my main.js file, if you hover over the gutter area right here, let me get rid of my file explorer here. If you hover over here, you can add a breakpoint. So see this red dot that's kind of following my mouse cursor? Let's say I want to investigate the value of is odd. I can put a breakpoint right here. Now it becomes bright red. This is going to actually stop my execution of my application when it gets to this line. Because I'm telling it, I want to stop right here and investigate what's going on in my application. All right, so with this breakpoint in place, I could go back to start debugging. Sorry, I keep scrolling that up. I want to run this file because this is my main file. Start debugging, the test file. And notice that it hit the breakpoint in main.js because main.test.js, I guess maybe I should explain this. We're using the contents of main.js in our test file. So that's why we're running the stuff that's in our main file here. So notice that my breakpoint got hit. So I have this yellow highlighted line. I got this pentagon looking thing in the gutter. That means my application is not running right now. It's actually paused on this line. So some things that are of our interest that VS Code offers is you can actually check out the values of certain variables in this panel right here. So notice there's a variables panel, and then it's showing me the value of is odd right now. So right now it's undefined because it's creating this variable here and going to assign it a value. So if you find your kind of run menu, which can kind of hover anywhere, you can move it around the top. If you hit this arrow button, it's going to go to the next line. Actually, let's go to this step over. This is actually going to proceed to take it to the next line. So if I click this, notice that my value of is odd just updated. Notice it's showing me that the value of is odd is false right now. I can investigate other things like hover your mouse over the value of I. Notice it tells me the current value of I. Can you guys see my tooltips? I'm not sure if that renders. Yes, tooltips?
Yeah.
Cool. Yes.
All right. Yeah, so you can see the current value of I, if I want to see what the value of array is, just hover over it. It shows me every content every index value. So notice index 4 is 0, index 1 is -2. But this is my first test case that's running. It's called this function and it passes in this array. That's what this test function is doing. But I know that one passes it. So, I can maybe put a breakpoint down here and get rid of my breakpoint here, because I don't want to keep running this. If I keep, hitting the play button, which means continue on, it's going to keep hitting this breakpoint because I'm in a for loop. So every iteration here, it's going to keep hitting that breakpoint. That's not what I want to do here. I want to actually get to this breakpoint. I guess I got through my list, but now I hit this breakpoint so I could continue on. And now in my second array. So if I look at array, this is my 8, 2, 0, -4, -1. So again, I want this -1 should return true from this function, right? Because -1 is an odd number. So let's kind of continue here. All right, we're on index value 0, right? I don't want to be at index value 0. I want to wait till index value is 4. So I can just kind of continue here. See, I is 2. Yep, so you see your I value right here. Notice it's by block level. So I have my array listed here and my I values. If I continue one more time, notice my I value now is 4. So this is actually the iteration I want to check, because again, our array, our fourth index, which is -1, should return true for is odd, right? So if I step one more time, I can check the value and yep, is odd is still false. That is not what I expected. So this, as a developer, I'm like, well, something's going wrong here. I know that I wanted this to return true because -1 is odd. Now what's going on here? Now, at this point, I could stop my code here if I want to make some modifications. So that's what I'm going to do. Let's say I want to get the result of this piece. So let's do let's remainder equals this operation. And then I'm going to use the remainder here just to get some more intermediate steps here. So again, I'm going to get the result of this operation, sort of remainder, and then see what remainder is. So remainder should be 1 for me to see that it's odd. So let me take away my breakpoints. I'm going to keep my breakpoint in my test file here. And I'm going to run this again through my debugger. So go back to run, debugger. All right, so notice I hit my breakpoint for my second test. It totally skipped over the first test because it ran that. I got my output right here, right? Test case 1 passed. That's what I was getting before. But now that I hit my breakpoint here, you can do, again, there's a few options here. Step into means it's actually going to go into that function. So notice I'm calling test my function here. If I actually hit step into, let's see where it takes me. Notice it took me actually into my test my function, because that's a function call right here. Step into goes into that function call. Step over would go to the next line here. So if you want to dig deeper, you want to step into, which is this option right here, or F11. F11 is a shortcut. All right, so if I want to go in here, notice it's calling another function here. So I want to step into that. So I'm going to click this again right here. And now it actually takes me to the function that's being called here, which is in main.js. All right, so that's obviously where I wanted to get to. I'm going to add a breakpoint here and kind of continue on. All right, let's check out my I value right here. Let me collapse a few of these panels. All right, so my I value is 0. I want to get to be 4 because 4 is my item of interest right here. So if I continue on, notice that remainder is 0 for all the even values, right? I2, I3. All right, when we get to I4, notice what we get here. It looks like remainder is -1. That is not what I expected, right? I thought anything with the remainder of +1 is an odd number. But it looks like for negative numbers, if you do a module operation, so this is some negative number, in this case, looks like it's -1 modded by 2. The result of that is -1, not +1. All right, so I think I've identified my problem here. Looking at my debugger, I got -1, but I wanted to get 1. So it looks like my logic right here is incorrect. I can't always check against 1 because we might get a negative number that's going to give us -1. So again, I think I've identified my problem. I got a -1, but I was not expecting that. How can I fix this? Well, I'm thinking a quick way, I can just do math.abs, which is absolute value. And now maybe any value I get, whether positive or -1, I'm going to compare that to +1. So absolute value should give me a positive value. All right, let's see if that works. So I'm going to go back to my terminal because I think that probably was fixed. So if I do node main.test.js. All right, cool, I'm passing that test case. All right, any questions about using the debugger? Again, breakpoints are the main name of the game. There's more advanced things you do. You can set conditional breakpoints. I'm not going to get into that right now because it's probably not worth the effort. But again, you could configure your breakpoints to hit only when a certain condition is true. That is possible. All right, so that's a quick demo of how you can debug using VS Code. Again, it's going to be much more beneficial when you have a lot of wheels turning. Right now, again, this is a very simple, algorithm, if we can even call it that. But when you have like large projects with tons of files, I really enjoy using debugger. There's command line debuggers that exist, so that is something that exists if you want to actually use a terminal for debugging. But I think VS Code is really one of the reasons it's really great is because it has a nice UI. It makes it really easy to kind of step through your application. Any questions on what I've done here? All right, so again, just get familiar with VS Code. So again, we talked about the file explorer, just shows you all your files in your workspace. We talked about extensions tab, where you could add a whole list of extensions, discover new ones. I'm sure you could find some really cool ones just by Googling or just typing random words here. And we talked about the source control tab. Again, this shows me everything I've modified. So it looks like I've modified my main.test.js. Per the requirements, we were not supposed to modify this. Obviously, I just commented them out. So, if I want to restore it, I should be able to just kind of match it up. And it should take away all those modifications. Cool. So now I'm back to where I was before. Notice it's not highlighting anything. So if I save this, main.test.js should go away because I only meant to modify my main.js file. And it shows me the changes here. All right, let's say I'm completed with this challenge. Obviously, I have a few more to go, but I'm not going to go through them because I'm sure you guys can solve it yourself or totally ignore it because this is not a real challenge. But let's say I've actually completed my challenge and I'm ready to commit this. This is going to go over the stuff that Raphael went over just shortly ago. I'm going to do a Git Add period. It's going to add all my changes that I've made. In this case, I've only modified one file. If I had like 20 files that I modified, Git Add period is going to add all those changes to your Git project. Now, just to reiterate, saving something and adding it to your Git project are totally different things. When you save a file, that's saving it on your local directory, whatever modifications you made. The Git Add actually adds the changed file to your Git project. So you know how Git is trying to manage your files, trying to spy on what's changed, what's different. Git Add tells it to actually commit, or not commit, but add it to like the staging area. If I do a Git commit now, -m, you want to add a good comment to kind of describe what changed. Because if you need to go back in time, let's say a month from now, I want to come back to this project and see what I changed. Let's say solved find first odd function, or maybe implemented. But always good to put informative messages here. So implemented find first odds function. We didn't complete everything. That's okay. Okay, so notice it tells me, all right, one file change. That makes sense because I'm only modified one file. It tells me I added 9 lines. This is probably 9 lines worth of stuff. I deleted 2 lines. That's probably the comment that I deleted. All right, cool. Assuming that that's cool, I'm going to do a Git Push origin. So again, this will actually transfer it from my computer back to my GitHub. So I'm actually saving it in the cloud, if you will, so that now, let's say my computer totally crashes, I have a copy online in my GitHub. So I'm going to hit enter. It's going to do some stuff, and everything looks like it went okay. So now if I go to my GitHub, day 1 challenge, not Quebec Platoon, but the personal GitHub. See if I can find it. Hopefully I did the right one. Okay, notice it has a timestamp. 1 minute ago, I submitted this. So that makes sense because I just committed this. I can take a look at main.js. Yep, these are the changes I added. Assuming I'm good, like I completed everything, there's one more step that we're going to ask you guys to do for your challenges. So in your personal GitHub, when you're on the challenge, there should be a pull request tab right here. Right, I'm going to click that pull request. Should take me something like this. I'm going to click new pull request. What we're essentially doing here is we're going to kind of submit a copy to Quebec Platoon. So we're going to hit new pull request. It's going to show me the changes from my personal GitHub. I'm going to do create pull request. I'm going to give it a title here. So when you guys are submitting, again, this is how you're quote unquote submitting your application. Please put your name in the title, just so it's easy for us to identify. I mean, we could look at your GitHub handle, but we don't have those all memorized and say who's who. So here, I might do like Encore's solution, and then it has the comments. That's fine. So I'm going to do, let me get rid of that. Say Encore solution for day 1 example. All right, so again, put your name in the title and then hit create pull request. So that's going to do something for a couple seconds. Just going to check for a few things. All right, so once you get the green check mark, that means you have officially submitted it to us, meaning we can review it. We can see that you actually completed a challenge. If we go back to Quebec Platoon, there should be a pull request tab. And notice I have, looks like Ivan has also submitted his solution. So here's mine, here's Ivan's. We should see all of your submissions here when you guys are done with your challenges. This is a way for us to track your progress and see who's completing challenges. Also, if I want to see Ivan's solution, I can go in here, go to his GitHub. Let's take a look at his main.js. Yep, so notice this is his solution. He uses single quotes, I use double quotes. Either is fine. But again, we can kind of see how you guys are solving these challenges and give you feedback if there's anything that we notice. All right, so that is the process of going from forking over a challenge, cloning it down to your machine, making the necessary changes to solve that particular challenge, then doing a Git Add, Git Commit with a nice comment, and a Git Push. That will push it back to your GitHub. And the final step, don't forget, is to do a pull request. So from your personal GitHub, you want to go to pull request, do a new pull request, and submit it so that we could actually see that you submitted it. Any questions on that process? Oh, we got another one. Looks like Grant has submitted his. Glad you guys were playing along at home. Okay, so again, VS Code, get comfortable with it. If you have any questions, again, we're not going to do too much with it. VS Code has a lot of capabilities. One thing that I like using are something called snippets, where if you're writing the same code over and over again, you can create a code snippet so that it automatically creates inserted code for you. Like I have a snippet for an HTML file. So I get, create my index.html. There's some pre-configured snippets. So if you hit exclamation mark in an HTML file, hit enter, it's going to give you like a bare bones HTML file for you. I did not just type this magically right now. VS Code automatically enter that in for me. You can create your own snippet. So actually I created one called HTML base, hit enter, and this is my basic HTML page where I can add on to it now, add whatever I want. So snippets are really cool. Again, that's just one of many features for VS Code. I'm sure you guys will discover new ones as you're developing with VS Code. Any questions on, again, setting up extensions, using the debugger, using the integrated terminal? Definitely want to make sure you guys are comfortable with VS Code.
I had a question about debugging.
Sure.
The example you used, everything was like the arrays were hard coded in. And in the past, when I've tried to use certain debuggers, when it requires input from a user, it is where I start to have problems. Does this incorporate that nicely? Like in the terminal there, does it run and like stop and prompt you for input at the appropriate areas and then continue to run and go to breakpoints and stuff like that? Or is it a lot more involved when it comes to like getting input from people?
No, getting input. So with Node, it's a little tricky. This is specific to Node. If we're coding in Python right now, I could just do it in 2 seconds. Python has a built-in input mechanism where, if I wanted to get the user's name, they could type in their name like here, and then Python will take that in. With Node, it is possible, but you have to actually install a library. It seems it's way harder than it should be. But I think for your challenge tonight, you won't have to use Node. I think we might have changed it to use your browser, which has an input mechanism. But to answer your question, no, the debugger will work fine. So when we were debugging it, you have the option to continue, as in it's going to run the rest of your application until it hits another breakpoint. So if I had like a line right here after my breakpoint that said, get username and had some input mechanism, again, this isn't valid code. But if this was like the point where it asked the user for a name, it's actually going to do that in the terminal. So you can still interact with your application. It's not like hands off or off limits. What other questions do you guys have about VS Code or anything else we went over today? Okay, last thing I want to show you, just get more familiar with our curriculum. We'll probably talk more about it tomorrow. If you go back to the curriculum project, there's a nice README down here that has some information that we went over and probably some information that we will go over. There's a nice diagram here. We might have shown this off during a pre-work call, but these are all the pieces we're gonna be learning throughout the cohort. So we're gonna be learning Python soon enough, SQL, HTML, JavaScript. We're gonna be doing something called Django framework, React. We're gonna kind of combine all these pieces together to what we call full stack development, where you're able to create an application from start to finish using all the tools that we're gonna go over the next 10 weeks. There's a curriculum calendar. I think we need to update this. So this link might be for the previous cohort, but this should show a summary of every single day what we're going to go over. So it's a nice summarized view. Student handbook, again, all useful links here. So if you want to review the student handbook, you can click this tab. It should take you to some document here. So you go through this again. This goes over, deadlines, policies, academic things might need to be updated there too. Slack etiquette. I think we went over this. But just go over Slack etiquette one more time. Where's my Slack window? It's here, I promise. Did I go to Quebec? All right, here's my Slack window. We might have gone over this in the pre-work call, but I want to make sure we're all understanding how we intend to use Slack. So we have our Quebec channel. Raphael wrote a message here. If I'm responding to his message, usually just respond in the thread. Instead of writing a message here, I'm responding here. This is going to create a new message here, and it's going to kind of clutter up, this chat, especially if we have like 40 plus people kind of chatting about different things. So if I were to respond to Raphael, I would say, oh, cool, I'll do that. So now I responded in the thread. So notice it shows that I replied with something. If anyone actually wanted to see what I replied with, they could check it out. But in this main view, it's not going to clutter up the UI as much. So make sure you're responding in thread if it makes sense to. If it's a one-on-one chat, yeah, you don't know how to use threads. It's just like a chat room at that point. So use threads. You can use reactions. Slack etiquette, as Raphael mentioned, try not to use like at here or at channel unless you really need to kind of notify everyone, because these are kind of noisy that notifies everyone, sends special notifications. So for the most part, you won't be using these kind of special channel notifications, but they do exist in Slack.
Hey, while we're on the subject of Slack etiquette, there's just one thing I want to add real quick. If you're trying to share code with someone over Slack, it can be hard sometimes because the formatting gets messed up when you copy and paste it. So one thing you can do is type in a triple backtick in Slack. That's the key just above your tab. Looks kind of like that. Just put it in chat. And then anything you type inside of that gets formatted like code. It uses a monospace font and it preserves the tabs and indentations. So in that block of text that I posted in the chat there with the questions, that was in the triple backticks. Okay, yeah, Ankur's giving you a better example here. So yeah, that's much easier to read. You'll find it, other people will have a much easier time helping you if you post your code in a way that's easy to read.
Yep, yeah, so try to use some formatting options. Again, not end of the day if you don't, but just get used to it because that's kind of what we do here. I'm going to delete my message. Talk about deleting messages. So please try not to delete your message unless like it's really a mistake. Even if it's like a question, you're like, oh, I figured out the answer. Still have it in there just to have a history. Again, we're not going to come yell at you if you delete messages, but it kind of gets confusing with like if I see a message and then it disappears, I meant to respond to it. So I'm going to delete mine because I didn't want my code there. But normally speaking, you shouldn't really need to delete messages unless it truly was a mistake or like you wrote it in the wrong chat and you don't want it there anymore. All right, Slack etiquette. Most of you guys should be fine with it. Again, there are formatting options, so make sure you use that just to make code a little easier to read. All right, so I got on this tangent because I was going through the curriculum page. So Slack etiquette, give that a read. Formatting mentioned here. This is the stuff that Raphael went over. So if you need, if you forget, wouldn't blame you because it's a lot of steps. This goes over everything you need to do to check out a challenge. So it talks about forking, cloning down. So you place repo link with the actual repository link that you're cloning down. Make whatever changes you want, do a git add, commit. Again, everything we went over today. is documented here on the curriculum page. So there's a README for the curriculum. That's what we're looking at right now. So if you forget, do that. We talked about daily check-ins. I think this forum probably needs to be updating. So we'll be doing this tomorrow morning. We'll go over it, promise. But if you ever forget the daily check-in form, this is one way to access it. Things you can do if you finish early. So sometimes you might be a go-getter and finish all your challenges. You could call it a day, but that's not going to lead to success later on. So always make use of your time. If you have extra stuff to do, Code Wars, great site, highly recommended to practice your coding. Because that's with anything. If I want to become the next greatest basketball player, I'm going to need to practice my dribbling and shooting and everything else every single day. It's not just like a one-day thing and you get better at it. It's a process. So Code Wars has a lot of examples and coding challenges you go through. I've not used Pramp or Interview Cake, but we'll check out Interview Cake quickly because it's been linked. All right, if you want to get better at interviews, take a look at Interview Cake. Again, I've not looked at this too much, so I might need to brush up on it. But again, some links there. Our YouTube. So if you click on this link, it should take you to our YouTube channel. This is where you can find playlists of everything from this cohort, but also from past cohorts. And this is a great resource. So sometimes, if you're trying to get ahead, you can look at a past cohort and see like week 2, what did we cover in week 2? Check that out. So if I go to playlists, scroll down, Pop-Up Platoon was our previous cohort. So if I want to see what happened in week 2, find Pop-Up Platoon week 2. And then we have a playlist of everything from that week. So it should be all 5 days listed here. If you want to just see what we went over last cohort, you're welcome to. Again, there's tons of videos here going back like 3, 4, 5 cohorts. So definitely use them if you want to. If you miss a day of class, we will be uploading the current day's lecture, usually over lunch, because lectures should finish up before lunch most days. They'll be uploaded. It takes a while to upload, so probably like an hour after we finish lecture, they'll be uploaded fully to YouTube. But there will be directories here for Quebec Platoon per week. So we'll create a week 1 directory, and it'll have Raphael's lecture from this morning. I'll add my VS Code lecture. And then again, if you missed it or just forgot something, want to have a good review, you should be able to get any video resource on this channel. So again, that you can find that link from the curriculum page, or you could just honestly go to YouTube, go to youtube.com, and then I want to type in Code Platoon. Yep, Code Platoon, there's a channel, and boom, you're right where you are. There's other videos. Check out some alumni stories. Discover the site. Plenty of videos to go watch. Any questions on accessing our Code Platoon YouTube or anything else about anything at all? I know that's kind of broad. Student resources, I guess, complete this page. These are resources that other students have kind of compiled here. It's not super extensive, but again, as we're going to like week 4, if you're getting acquainted with Django, check out some of these YouTube links. These are what other students have recommended. We have not necessarily vetted them, but again, some people found css-matic.com. If you want to fiddle around with box shadows, great. Jack Schuff has left you a resource that he found was beneficial. Highly recommend if you guys find a cool resource, just add it onto the student resources page. That's going to benefit people in the next cohort and even people in this cohort. All right, that's a lot to go through, but again, a lot of useful links on the curriculum page. So if you ever get lost, you can probably find your way through this page. All right, with that, I'm going to stop the recording. Were there any questions? So again, I can't always see the Zoom room when I'm presenting. Were there any hand raised that I missed? Okay, so it is approaching 4 o'clock. Again, this was a super long lecture day. Every day from now on out, it's not going to be this long. We're going to complete lecture before lunchtime, and then every afternoon you'll have time to work on your challenges. But for today, as Raphael mentioned, you have 2 challenges. You have 99 bottles, and you also have a challenge called Deaf Grandma. So read them over, just get them started. We're going to do our stand down at 5 p.m. So you're going to have roughly an hour to work on challenges for today, but most days you'll have a full 4 hours to work on them. All right, so to get started, if you get stuck, reach out in the Quebec questions channel, and we'll gladly assist you when we're available. All righty. Okay, cool. We'll see you guys back in the main room for our stand down at 5 p.m.